Hello everyone, I welcome you again in my lecture. So today we are going to talk about analyzing the program code. We will find out the running time of these codes. So let's start. So when we write a program code or when we write a logic for any problem, when we write the code for it, we write the code in generally either using a iterative approach or a recursive approach. So you can see that when we talk about any program, the program can be written either using a recursive approach or an iterative approach. So when we say iterative approach means we are making use of loops. We are using a while loop, for loop, do while loop. These loops are generally used when we write the iterative approach. In the recursive approach, we define a function which performs some task, and in return it will call the function itself. This is a recursive approach, and the two important thing for the recursive function is that it will call itself, and also it must define some termination point. There must be some exit point that will stop that recursive call. So let us talk about a function Fibonacci. So if I am going to write a Fibonacci using a iterative approach, then it will be something like this. But you must be knowing that what is Fibonacci. So Fibonacci series is something like this. We have 0, 1, where we keep on adding the two terms to get the next term. So 0 plus 1 is 1, 1 plus 1 is 2, then 3, then 5, then 8, and then 13, and so on. This is a Fibonacci series, and if we want to write a program to represent the series, then we can do in both ways. Either you can do iteratively and recursively. So I believe that already you have been writing programs in your OP2 lectures. There you have already written this. Let us look at the logic. So we will write the algorithm. So if I write Fibonacci, so let's say this is a function which we are writing. So I am going to pass one integer value. This is int n, and we need to also take some variable to complete our logic. Let's say we have first number is 0 and the second number is 1, and then we are going to collect the summation of the first and 2. Initially it is 0, let's say, and then we can make a kind of for loop, and this for loop will be going to run for n time. So it will start and it will go for n number of times, and here you can do the logic where we are adding the first two values, the first and the second, and after adding it we are proceeding that the second become first and the result become the second. So I am going to write here, we assign the value of second to first and the value of result to second, and so on, and it will do it for n number of times to get this kind of result. This is our iterative approach. Here the function fib is not calling itself. Now if we go to the recursive approach, we will do something like this. We write Fibonacci is the name of the function, let's say, and here we are passing one number, let's say n, or let's say num, and it will return, means after doing some logic it will be returning you value. So here we will check if the number is actually 0, if num equal to 0, then that means we are actually returning the first term, so we'll return 0 only. If num equals to 1, then you will be going to return 1. Or if or you can say else if, means if this is 0 then return 0, if the value if num equals to 1, return 1. Otherwise we need to do it recursively. We need to call this function again and again. Okay, so in that case what we are doing, we are saying if else if, we will going to return what we are returning? We are saying return the fib num minus 1 plus fib num minus 2, something like this. So this is a just a rough idea that we have taken here. The purpose of discussing this idea here is we can achieve this task by either writing a iterative program, or you can also write the recursive program. So as a result, you will get the same thing, but in terms of performance, in terms of the behavior of the algorithm, there is a very big difference in the two approaches. For this program, iterative approach is actually a better approach. So for small values of n, means if you want to get only the series for first five, or you can say 6 or 7 or 8, then you can see that recursive may be good. But when we go to larger series, if you want to find this for a larger series, if you want to print first 100 or first 80 or 50, in that case you will realize that recursive approach is actually very very costly, because in the recursive approach we are using stacks, and every time when you make a call, these values need to be passed to the stack, and these values are to be stored there, and then when the next function is being returning the value, that value is being passed to the previous hold values in the stack. So it will take a lot of time, and also it will consume lot of space as you compare with the iterative approach. So here we will just see the running time of these two algorithms. In case of iterative approach, the running time is big O of n. What is the size of n? That is the running time, and the space complexity is actually constant. So when you keep on doing these operations, you are not going to hold the result. But in the recursive approach, when you make a call to another function, the previous the callee function need to hold the values of this variable. So here, if you look, it will be big O of fig of n, you can say, which is actually exponential, which goes to 2 power n. So this is order of 2 power n. And in terms of a space complexity, you need to have big O of n. So in terms of space, in terms of time, both are having a larger values for recursive approach. So what is the purpose of discussing here is, the purpose of discussing here is we can do the same problem using the two approaches, but you must be knowing that the two approach, though producing the same result, but the performance behavior is a big difference. So as a good programmer, we need to always use the approach which will give you efficient programming, which will give you the better result in terms of it will take less time, it will consume less memory. So let us take some more codes, and we will understand that how to analyze these codes, how to find the running time of these codes. So let's start. Okay, so let us take a very simple code here, and you will see what is the running time. So here we have int I for I equals to 1 to n, and this print message. So that means we need to do this task, and we are doing this task for this number of time. So this is simply to find out the running time, we need to find out that how many times we are doing a basic operation. So here we are just printing this message, how many number of times we are doing n time. So the running time is simply big O of n. This is the simplest evaluation of running time. Moving to next. So here, this is one code, this is other code. Let us see one by one. Now we have a for loop I equals to 1 to n, and then we have for j equals to 1 to n. Now here both the loops are actually dependent on n, and these are actually independent of each other. Means j is not dependent on the value of I, but it is dependent on value of n. So whenever we do this kind of scenario, whenever we come across this kind of scenario, this is called nesting. You can simply find out the number of times operation performed in the outer loop and inner loop, and then you multiply. But if it is not a nesting, then you have to find out the number of operations of both the cases, and then you have to add simply. For example, if I say for I equals to 1 to n, and you are performing some operation, and then also you are doing for j equals to 1 to n, and you are performing some operation. So here we are not doing nesting, so you have to find out we are doing n number of times some operation, we are doing n number of times some operation, so the cost is n plus n, which is big O of n. One thing to understand that whenever we try to find out the running time, which we call it t of n, we are only interested to find out the nature. We need to find out that how the function behave in terms of n. We are really not interested to find out the actual value, but we are interested to find out the nature of this function. Now here you can see, here we are doing this operation n times, here we are doing this operation n time. So that means now this is a case of nesting. So whenever we are doing nesting, that means this j loop is going to execute for every single value of I. So for when I equals to 1, it will do n times. When I equals to 2, it will do n times. So this means the total efforts or the total time it will take is big O of n square. Okay, so this is again the big O of n square case. If you understood it, that's okay. You can move to the next part. Otherwise, let us see that how this big O of n square will be evaluated. So this is one function. It will take some input n, and we are interested to find out what is the running time. We have three variables, and again, this is a nesting case. But here you can see here these are not independent. Independent in the sense that here the j is actually behaving on the basis of I. On the basis of I, the value of j will be actually calculated. So here we cannot simply do this kind of multiplication, but we have to identify that at each value of I, how the iterations are going. So we have to find out that in the first value of I, it will go this number of times. In the second number of for the second value of I, it will go how many number of times. So we need to generalize it. We need to find a general sequence that how every time this code is working for each value of I, and that for general value and then for that generalized sequence we need to find out what is the running time. So what I mean to say is, so here I equals to 1 to n, j equals to 1 to I, and this is for example, so here I can write when I equals to 1, j is equals to actually 1 only, so it will go 1 to 1, so it has j will also will go one time, and inside the j we have k, which is going to execute 100 times. And so 100 times 1 into 100 means for each j it will going to execute these number of times. So here j is 1, so we are going to execute this loop 1 into 100 times. When I becomes 2, so here you can see that j is going to have two values, 1 and 2. That means it is going to execute 2 times. And inside the j we have a k which is going to execute 2 into 100 times. Similarly, let us see the behavior. When I equals to 3, j will have 3 values, so it is going to execute 3 times, and then k is going to execute 3 into 100 times. So here the loops are dependent on the outer actually layers, you can say, or the labels, you can say. So we need to find out the number of execution at each iteration, and then we need to generalize that how the things are actually working here. So the total effort which is required to execute this code is this plus this plus this. So if you find out, so we actually executed 100, then 2 into 100, then 3 into 100, then so when it goes, when I equals to n, then j will be going to execute n times, and the k will be k into 100, n into 100. So here you can say it will go up to this n into 100, and this will give you a sequence. You take 100 common, and then you get 1 plus 2 plus 3 and so on, and this is just a addition of first n numbers, so you can say n into n plus 1 by 2, so that means this is nothing but big O of n square. So the running time is big O of n square. Okay, moving to next. The next we have a function. It looks a very simple function. Let us find out how the things are working. So here, while n is more than 1, it is keep on going like n by 2. Let's say we are going to pass one value here, integer n. Just let us redefine this function. We are passing one n, and then based on the value of n, it will going to execute. This is keep in mind, this is just a pseudo code. This is not an exact code of any programming language, because I am not considering the syntax kind of consideration. So there are a lot of mistakes maybe there in terms of syntax. So we are just focusing on the key steps of any algorithms. So this is a function where we are making this kind of loop. So let us take an example. If the value of n is, let's say 4, then what is going to happen? It will be going to become in the first iteration become 2, and then become 1, and then it will stop. So that means you did 2 iteration. You make 4 by 2 is 2 and 2 by 2 is 1. So you did 2 iterations. When you are going to do, when let's say value of n is 8, then it becomes 4, then 2, then 1. You did 3 iterations. So you can look here. So here you can observe one behavior. So if you find log of 4 base 2 is actually 2, log of 8 base 2 is 3. That means if I am having this kind of scenario where n is going to half every time, then my answer is log of n. And if you are doing n by 2, it is base 2. So if my value is n equals to 8, then my answer is log 8, and this is only applicable when every time n is going to be half. So I will say log 8 base 2. In case of n equals to n by 2, if I make it n equals to n by 3, that means I am decreasing my value of n by divided by 3. That means my answer will be log of n base 3. If I am going to make it n by 6, then my answer will be log n by 6. Similarly, whatever the value of n is actually behaving, how far it is decreasing based on this division, you can find your answer. This is one important result. So you just keep a note that how to find directly this kind of results. So the answer is log n here, and here because we are dividing it by 2, so this is log n base 2. So order of log n base 2 is the answer in our case. Okay, let us look at this function. Again, you can see this is a nesting scenario where we have I, j and k loops are there. But this is not independent, because here j is depending on I. So you can see here that for every value of I, the behavior of j depends on this value of I, and the k is actually depending only on n by 2. So let us see that how it works. We have to find out that how each iteration is actually performing. So when I equals to 1, j is actually going from 1 to 1, okay, and the k will be 1 to n by 2. So it will be going to execute n by 2 only one time, because it is dependent, it is nested inside the j. So because j is 1, it is going to execute 1 into n by 2. When I becomes 2, for the value when I equals to 2, j will be going to execute uh, up to 4. Means j will 1, because it is incrementing linearly, so it will 1 2 3 4. So it will take 4 values. Similarly, k will be having 4 times n by 2. because it will go from 1 to n by 2. Whatever the n you are passing, it will go half the values of n. Then when I equals to 3, j will be 1 to 9, and it will be 9 into n by 2. This is how the things are working. So if you go on this way, for I equals to k, for some value of k, then j will be 1 to k square, whatever the value of k, you will just have to go up to the k square, and this will be k square n by 2. That means if I want to generalize this kind of pattern, so the cost is this plus this plus this, because in the first iteration we are doing these many these iterations are involved, in the second this, third this, fourth this. So we need to find out what is this kind of series. So we will see n by 2 plus 4 into n by 2 plus 9 into n by 2, so on, k square n by 2. So you can take n by 2 common. You can get 1 plus 4 plus 9 plus k square. Okay, and you can go up to this n. So what is the series? This series is actually n by 2. This is 1 plus you can say 2 power 0, not this, 1 square, 2 square, 3 square. Okay, this is a square series. 1 square, 2 square, 3 square, k square, and so on. So we need to use the direct result. The summation of the series is so n by 2, and this is actually n into n plus 1 plus 2n plus 1 by 6. And if we solve this, we always interested to find out the highest order term. So we have 1 2 3. This is big O of n raised to the power 4. This is the running time of this code. Okay, so moving to next. Okay, let us look to the next code, and we will see that what is the cost in terms of running time. So we have I, j, and k, and here also you can see that j is not dependent on I, and k is also not dependent on j. So we simply find out the number of iterations in the each loop, and then we simply multiply, because here they are independent of the outer loop or the outer labels. So here I is going to iterate n by 2 to n. That means it is going to iterate n by 2 times. This is again going to iterate 1 to n by 2 and incrementing linearly. So again it is going to do n by 2 number of times on this operation, and here it is going to k equals to 1 to n, and k is incrementing by just doubling every time. And we have already discussed that whenever we are doubling a sequence, means the value which is going to define our loop. For example, if it is going not like 1 2 3 4, but it is going like, so instead of going the value like 1 2 3 and 4, it is going like this: 1, and then 2, and then 4, and then 8, and then 16. If this is the behavior of the iterating variable, in that case we have the result log n, and because we are doing multiply by 2, this is log 2n. So what is the total cost? You can simply multiply this. We are doing a nesting operation without the dependency of these variables. So it will be n by 2 into n by 2 into log n, which is big O of n square log n. Okay, so moving to next. Okay, so let's have a look to this kind of code. Here the running time will be of this nature, big O of root n. So here we have a function which is defined in such a way. We have two variables, I equals to 1, sum equal to 0. We have a while loop which is defined in terms of some condition we can see here. Now here you can see that I is incrementing linearly, means I is going 1 2 3 4, and sum is actually in increasing based on the value of I. So let's say when I equals to 1, so initially let us understand that how the value of I and sum is actually determined. So when I equals to 1, sum is initially 0. So sum is 0 is less than equals to 1. Yes, this condition is true. So we will go inside the loop and sum will be 0 plus 1 is 1. Sum will be 1. Then I becomes 2, and sum will be what? Sum will be 2 plus 1, that is 3. Then I will be 3. Then it is going to add a previous sum value and I, that is 6. Then I equals to 4. Sum will be 10. This is how the things are working. So depending on the value of n, it will be going to execute. Means if you say if n is 10, it is going to make only 4 iteration. If you say the value, if you want only 3 iterations, then n must be near about like 6, more than 3 and less than 6. So here we can see the nature of the sequence, and here you can realize that this is basically a kind of series. So if I want to get this sum is less than equals to n, means if our n is defined, means sum is going to be keep on incrementing until it becomes n. Now to make this sum equals to n, how many I will be required, means we are going to make how many iteration so that the sum is going to reach to n. Let's say this is k. Okay, so now what you will observe here, you will observe here that that this value is actually the sum of the first n numbers. What does it mean? That means if you look at this value, then just you add the first two numbers, 1 plus 2, you get 3. If you want the third term, then 1 plus 2 plus 3. If you want this term, then you have to add this. That means if I want to get this n, I need to add 1 plus 2 plus 3 up to k. So this is something 1 plus 2 plus 3 plus 4 up to k is actually giving me this nth value up to which the loop is going to execute. So I need to find out how many iterations I am going to make to reach to k, and k is what? K is actually this kind of sequence we are getting. Now what is this? This is just a AP series that can be find out by k equals to k plus 1 by 2. So this value, whenever this value becomes more than equals to n, this is going to actually stop. So here you can say that this is k square plus k is should be more than equals to n. Now here if you see, so this term can be represented as big O of k square. Our effort is this. This is our defining our effort. We are actually doing in the first iteration we are doing 1, then we are doing 2, then we are doing 3 iteration, then we are doing 4 iteration, then we are k iteration. So if we are reaching up to here, that means we are doing this plus this plus this plus this plus this plus this, and this is k into k plus 1 by 2, that is big O of k square. So uh, our cost is uh, our cost is actually defined in terms of k. So we can say that k is equals to root of n, because we have already find out that k is actually the relationship between the k and n is k square plus k is actually n. So we can say that the k is root n. So our cost is big O of root n, because our interest is to represent this entire code in terms of n, not in terms of k. K we are using for some internal manipulation to identify the nature of the sequence, and then we can represent the entire calculation in terms of n. So here this is big O of root n. Okay, okay, look at this code. Let us understand how this code is working. So here we have one loop, and we need to print one message. So our objective is to find out how many times this message is going to be printed, or we need to identify actually how many iterations we are going to have in this kind of loop. So we will understand this by writing the values of I and its behavior. So we can say when I equals to 1, then this condition will be holding true because I square is actually 1. That means if the value of n is less than equals to 1, then only you are going to execute this loop. When I becomes 2, then it will be going to work when n is less than equals to 4. Similarly, when I equals to 3, this is 9. When I equals to 4, this is 16. What does it mean? It means if the value of n is more than 9 and less than equals to 16, that you then this loop is going to iterate only 4 times. So here I am taking the value of n as a square number just to make the thing simple. You can also take the value as 24 also. Let's just take the value of n is 25. So that means uh, I will make only 5 iterations, not more than this. So how to find out the general behavior, how we can compute this particular kind of sequence. So here you can see, now here we can represent this row in terms of I. So you can say this is I square. So here you got this. That means if if I am going to if I am going to give n value, then I need to make k iterations, and this is my cost because this defines the cost. So if I make one iteration, the cost is 1. If I make 2 iterations, the cost is 2. So if let's say to get up to the value n, I am going to make k iterations, and the relation between this and this is the two rows is that a n is equals to, or you can say the k square is equals to n. That means I can say that k is equals to root n, and my cost is big O of k, that is actually means big O of root n. So the cost of this course big O of root n. So this is all for this lecture. In this lecture we have discussed that how to compute the running time of various codes. Our main focus on this lecture is to find the running time of iterative code. In the next lecture we will be discussing that how to find the running time of recursive code, because we will see that the same program when written using different approaches, their performance is different. So as a programmer you must be knowing all these things, and you need to decide that which approach will be good for you. Okay, that's all for this lecture. Take care, and we'll see you in the next lecture.